So we're still on the same section, 7.3. We're still talking about logs. So we've already talked about simplifying logs. We've already talked about changing a logarithmic form to exponential form. We've even already touched on finding the inverse, right, of logarithms and finding the inverse of exponents. So let's dive in a little deeper into finding the inverse. So it says we already know to find the inverse of any function we must switch x and y, switch them, and then solve for y. Example, to find the inverse of this guy, you're going to take that x and take this y and switch them. So you're going to have x here and y there. Okay? And then you have to solve for y. So how do you solve for y? In this case, well, you would add 8, and then divide by 2 and divide everything by 2, and you end up with your inverse function. So we're going to use that same process to find the inverse, but we're going to apply a few tricks, right? So here's something that we need to understand. It says you could magically add a log base anything to both sides of your equation. Or you can raise both sides of an equation to be the powers of base A, of a base of your choice. Okay? So that sounds a little confusing, but check it out right here on this problem. Let's say we wanted to find the inverse of y equals 6 to the x power. So you're going to switch x and y. It'll say 6 or x equals 6 to the y power instead of y equals 6 to the x power. You switch them. And then after you switch them, you need to solve for y, but the problem is y is an exponent. So we need to make that y come down to be a regular y. I don't want it to be an exponent. So when I don't want something, I do the opposite. If I happen to have had a plus 3, and if I don't want the plus 3, I do the opposite of plus 3, which is a minus 3. In this case, if my y is an exponent, and I don't want that exponent, I want to undo the exponent with the inverse of an exponent, and the inverse of an exponent is a logarithm. So if you want to get rid of this base 6 exponent situation, you're going to have to apply a log base 6, so it'll cancel out and the y comes down. But what you do to one side, you have to do to the other side, apply a log base 6 over here also. And that's what I explain right here, that we magically add a log base 6 to both sides of this puppy. I don't know why I call it a puppy, but anyways, this equation. So we magically add a log base 6 to both sides, and of course, the log base 6 of 6 cancels out, the y comes down, and there's your inverse function of the original exponential growth function. Example number 2, find the inverse of this guy. How do we find the inverse there? Well, we're going to switch x and y, okay? And that's what I explain here. We switch x and y. So instead of y, it's going to say x. Instead of x, it's going to say y. That's what we have here. And now we magically raise both sides of the equations to be the powers of base e. Okay, so my point is this. If I have this equation and I want to solve for y, where's y at? It's inside the parentheses. So I don't want these parentheses, and I don't want this log base e. I don't want this ln. So if I want to get rid of something, I do the opposite. What is the opposite of log base e? It's raising it to be the power of base e. That's the opposite of log base e. So what I want to do is magically take this whole thing right here and raise it to be the power of this big giant e. But of course, what I do to one side of the equation, I have to do to the other side. So I want to take this x and also raise it to be the power of base e. So I'm going to put a big e over here. And the equal sign, I'm just going to bring it down between the two e's. So my new equation is going to look like this. It's going to look like e to the x equals e to the ln of y plus 3. And of course, e to the ln, it cancels out. And you end up with the new equation that says e to the x equals y plus 3. No more exponent. This guy comes down when the e to the ln cancels out. So I explained this on the next column. Let's move up here. So there it is. I raised both sides of the equation to be powers of base e. The x was a regular x. Now the x is an exponent of base e. This was ln of y plus 3, but I made it be the power of base e. And now we're going to cancel out this. The y plus 3 comes down, and the e to the x comes down. My final step in solving for y would be to subtract 3. So you're going to subtract 3 there, y equals e to the x minus 3. And I didn't have to write it because it's already explained and done for me right there. Y equals e to the x minus 3. And that is the inverse function of y equals ln of x plus 3. Bless you. Okay, so how about we try some of these? Let's find the inverse of this one. What's the first step? Switch x and y. So we have x equals log base 7 of y. Always write your bases small, please, because then it starts looking like a 7y instead of base 7y. Anyways, we switched x and y. Now let's solve for y. What do I need to do? I want to get rid of the log base 7. Raise it to be the power of base 7. Right? So we're going to take the whole right side and raise it to be the power of base 7. And then what I do to one side, I have to do to the other. I want to take the whole left side, raise it to be the power of base 7. And here's my new equation. It says 7 to the x equals 7 to the log base 7 of y. So this equal sign up here, you could scratch it out. We really just brought it down. Okay, so we have 7 to the x equals 7 to the log base 7 of y. Now, why would I raise it to be the power of base 7? Because I know that 7 to the log base 7 cancels out, which means my y is going to come straight down. So on the right side of my equation, I just have a y. I have a y. Then the equal sign, and on the left side, I simply have a 7 to the x. Ladies and gentlemen, that's it. That's your inverse function. Y equals 7 to the x power. That's your inverse function of y equals log base 7 of x. Okay? You got it? All right. How about this guy? Y equals 8 to the x. If I want to find the inverse, I'm first going to switch x and y. Now I need to solve for y. Let me actually make a little more space here. So how would I solve for y? Y is an exponent. I do not want it to be an exponent. I want to get rid of that exponent. I want to undo the exponent. How do I undo something? With the opposite operation. What's the opposite of an exponent situation? A log. Right, Nick? Yeah. So what kind of log am I going to apply? A common log? A natural log? What kind of log? What kind of base am I going to apply? Log base what? Log base 8. Why am I going to apply a log base 8? Because log base 8 of 8, what happens? Cancels out. That's the whole purpose. Cancels out. The y comes down, equals. But then again, if I apply a log base 8 on the right side, I have to apply a log base 8 on the left side. So I'm going to end up with log base 8 of x. That's your inverse function of the original y equals 8 to the x. And that makes total sense because the inverse of an exponential growth function is a logarithmic function. The inverse of a logarithmic function is an exponential growth function, or decay, depending on your base. How about number 3? How do I do that one? Log base e. Log base e, right? Or you could say the fancy words natural log, right? Or you could say ln, because it's all the same thing, right? We're going to apply an ln right here and an ln over here. Actually, I'm sorry. First step to do. What's the first step? I forgot. Switch x and y. Okay, so we have x equals e, that's ugly, to the y plus 3. And now we're going to apply an ln to get rid of that base e so we could get that y to come down. So we're going to apply an ln right here, an ln right there. So the ln of e, that's log base e of e, cancels out. Your equal sign comes down. You have y plus 3. And then on the left side you have ln of x. Now we still need one more step to solve for y. What would that be? Subtract 3 here. Subtract 3 over here. You can't really do it, so you're just going to rewrite it. So your inverse will be ln of x minus 3 equals y. So what I want to do is compare that with this next one. This next one, I want to find the inverse. I'm going to switch x and y. X equals 2 to the y power minus 3. Now, I already switched x and y. I want to solve for y. What am I going to do? But before that, when I say solve for y, you want to get y by itself on one side. There's something that you could do first. Plus 3, right? The nice and simple adding 3. What you do to one side, do to the other side. So right here, you really do have x plus 3 equals 2 to the y power. Yeah? And make this equal sign a little smaller. That's ugly. There. Okay, so we have x plus 3 equals 2 to the y. And now, I'm going to apply what to make that y come down? I have it as an exponent. I don't want it as an exponent. I want to undo the exponent. So what am I going to do? Log base 2. That's right. So let me zoom in here. Let me do log base 2 of 2. And what I do to one side, I do to the other side. Now, this is a very, very important detail, guys. When I apply log base 2 on this side, I can't just do this. I can't just write it like that. You know why? Because that says log base 2 of x plus 3, and the plus 3 is out by itself. So if I'm really applying the log base 2 to the entire left side, I need to put parentheses around the x plus 3. Does that make sense? Okay? So on the right side, yeah, log base 2 of 2 cancels out. The y comes down. This y comes down. The equal sign's right here. And over here on this side, I have log base 2 of x plus 3. That's your answer. The inverse of the original. So in reality, comparing number 3 with number 4, they're both exponential functions, and when we found the inverse, they turned to logarithmic functions. But what I want to mention here or emphasize is that this guy does not have parentheses around the x minus 3. And this one does have parentheses around the x plus 3. Why is that? Well, because up here, we had a y plus 3 in the exponent. We took the ln first, and then the y plus 3 came down, and then we got rid of the plus 3 by doing a minus 3 after applying an ln of x. So you really do have ln of x, and then after doing the ln of x, you do a minus 3. But over here, we got rid of the 3 first, and then we applied the log base 2 to the whole binomial, which is why we have parentheses around that binomial. Does that make sense?